Okay. Go ahead and write these down, and then we'll jump right in just a second. Okay, so when we talk about series, we are not really talking about like something conceptually way different from a sequence, okay? The sequence is your pattern, okay? And when we switch over and we start talking about a series, we're not talking about a different type of pattern, okay? We're just applying a different concept to sequences. You follow what I'm saying? So when we talk about sequences, we're talking about the pattern. When we talk about a series, we're talking about an accumulation of that pattern. Y'all know what I mean by accumulate? What do you do when you accumulate? Yeah, you add it all up, right? So this says that the series is the sum of the terms in a sequence. Now, when we look at a sequence like this one, this first one, what do we call that? What kind of sequence is that?
Natural numbers.
Huh?
Natural numbers?
No. I mean, yeah, they are natural numbers. You're right about that. 1, 2, 3, 4. Those are your counting numbers. But yesterday, remember when we said it's in a set like this and there's no dot, 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 what do we call that? Start with an F. Finite, right? So that's a finite sequence. So it's really simple to find a series of a finite sequence, right? What do we do with them all? What does sum mean? We add them all up, right? So in this finite sequence, the sequence that stops, we're just going to go 1 plus 2 plus 3 plus 4. That's it. That's the whole sequence. So the sum of that sequence is going to be 1 plus 2, which is 3 plus 3, which is 6 plus 4. So my answer is 10. 10 is the series of that finite sequence. But if we look here at this next one, I can do 3 plus 6, that's 9, right? 9 plus 9 is 18. 18 plus 12 is 20. But what about the dot, dot, dot? Can I find the sum of this? Say that louder, Trevor. That's exactly right. It's infinite. Okay? Dot, dot, dot means this thing's going to go on forever. And since it's going to go on forever, it's going to keep on accumulating forever. And we call forever in math infinity. So the sum of an infinite series that's increasing like this, the answer has to be infinity. What if it's decreasing? What would it be? It'd be negative infinity, right? So again, that's something that would be common that you might run into, you might see. Then you got another one. This 1/2, 1/4, 1/8, 1/16. You notice that thing is it's getting smaller and smaller and smaller and smaller and smaller. Would that approach infinity? Since those values are so small? No, it actually would approach the answer or the solution 1. And you're not going to see those as often. But again, when we talk about a series, we're talking about a summation of a sequence. That sequence might be finite, it might be infinite. But most of the time, when we talk about these, we're going to ask for a partial sum. It's going to say S sub n. and it's going to have some number in nth spot. So before we look at this, I want you guys to make sure and keep these two things, these two concepts separate. A sub 9 and S sub 9. A sub 9 we talked about yesterday, right? A sub 9 means what is your ninth term's value? That's it. A sub 9 means what is your ninth term's value? So you're looking for a single value that represents your ninth term. Y'all with me on that? But when you see S sub 9, it means what is the sum of all of the terms all the way up to the ninth term. So S sub 9 would mean you take A sub 1 plus A sub 2 plus A sub 3 plus A sub 4 plus A sub 5 plus A sub 6 plus A sub 7 plus A sub 8 plus A sub 9. You add up all of the terms up to your ninth term. So please keep distinguish the difference between A sub 9 and S sub 9. A sub 9, A sub n is just an individual term. S sub n is a sum through that term. Yes, sir?
So, could you just multiply by 5?
Like on this problem?
Yeah.
No. No, because if you just multiply by 5,
yeah,
it's not representative of all those values that you haven't solved yet. So for example, if you look at this one, it wants me to find the sum of this sequence through what term? Through my ninth term. Well, how many have they given me so far? They've given me 5 of them, right? They gave me 1, 2, 3, 4, and 5. Do we know the 6th? Pretty obvious, right? What's the 6th? It's 6. What's the 7th? It's 7. What's the 8th? 8. And then finally, what's the 9th? 9. So here's my sum of this sequence all the way through the ninth term. Okay? So here's how we would answer this. We would say S sub 9 equals, and then we're going to accumulate these. Again, you can use your calculator if you like, or we could use our brain. What's 1 plus 2? 2 plus, or 3 plus 3? 6 plus 4. 10 plus 5? 15 plus 6. 21 plus 7. 28 plus 8. 36 plus 9. So the sum of this sequence through the ninth term equals 45. 45. Any questions with that? Does that make sense? Now you might have a problem like number 3. It's a little harder, maybe. Because they want to know the sum through the first what? 6 terms. Well, we know the first term is 1, second term is 4, third term is 9, fourth term is 16, fifth term is 25. The only reason this would be harder, we need only one more term, right? The only reason this is harder is some people might struggle to see what the pattern is here. Does anybody know what the pattern is? Do you might know these are what? They're perfect squares, right? Look, isn't that the first term? Well, what's 1 squared? 1. Isn't that the second term? What's 2 squared? 3 squared, 4 squared, 5 squared. So what do you think the 6th term will be? And what is 6 squared? 36. So now I can add all these up. Some people like to start with the bigger side. 36 plus 25. I don't know what your preference is. Honestly, it doesn't really matter. When the numbers are bigger like this, a lot of times you guys will just use your calculator. Okay? Your call. But 36 plus 25 is what? 61. 61 plus 16 is 77. 77 plus 9 is 86. And plus 4 is 90. 91. Is that what y'all got? 91. So S sub 6 equals 91. So these are called partial sums. It's finding the accumulation of a sequence through a specific term which is denoted by S sub n. Okay? Any questions with that? There's also another way for these to be written, and we call this summation. We call it summation. Does anybody know what that symbol is? For real?
Is it the E?
Yeah, that E. Does anybody know what it's called?
Is it,
Some people think it's epsilon because it's E, but it's actually not. It's sigma. Okay? Sigma. E for effort? No. Sorry. We don't give E's anymore. So, we left E's a long time ago. Yeah, no, you've been dealing with A, B, C's.
I was just saying.
Huh? It's not. Okay, so just drop it. Wonder why they do skip E and go straight to F.
because F is failed?
Yeah, I guess.
I mean, what would E be? Because obviously
It used to be excellent.
No, but that doesn't make any sense.
It used to make sense.
E for effort.
Okay, anyways. Alright, I think E's used to be excellent, didn't they, in like lower grades?
I've never had E.
Yeah.
You never had E's, that's maybe a reason. You had a bunch of S's, huh? Satisfactory?
Oh, no, I didn't get S's either.
You had U's?
No.
Unsatisfactory?
What grade are you talking about?
You had N's, didn't you? Needs improvement?
Yeah,
I'm messing with you. That was like elementary school grading, wasn't it?
I don't know, I just got stars.
I don't
I know
remember,
what you're talking about.
I don't remember A's and B's on those
I
report
remember
cards.
A's
I
and B's.
do, I remember E.
You guys are so young though, so y'all probably did get A's and B's and stuff like that.
Did you not?
No, we had like E's for exceptional, S was satisfactory, N was literally needs improvement, and U's were unsatisfactory. That's what we had when I was your age.
What'd you have?
Like what grades did I get most of the time? Probably E's and S's.
U's.
I did pretty good. Now on my behavior, I sometimes got U's because I was a little chatty.
You still are. You're a baby.
No, I wasn't bad. I couldn't sit still. My teacher would make a deal with me. She'd put me in the back row, and I could stand up and work, which was good for me because sitting down was really difficult.
Did you make all A's in high school?
Yeah, I had 4.0.
Oh,
Yeah.
that's or whatever. Yeah.
He asked me. I'm not like.
Wow.
Do you want me to respond to the question or just be like, I don't want to talk about it?
Oh, yeah. Better say you don't want to talk about it.
Okay. Yeah, I was. It was pretty. High school was pretty easy for me. Yeah. All right. Anyways, let's move along. Here's what summation says. Okay, I want y'all to hear this. Okay, summation basically says this: it's the sum of the sequence represented by 2n. Explicit formula. We'll write that down over here in a second. It's the sum of this sequence from the first term through the 5th term. One more time. What you see when you see this sigma, the summation, it's saying to you, we want to find the sum of this series, of this sequence, 2n, from the first term all the way through the 5th term. Y'all follow?
Yeah.
So this right here has to be an explicit formula. It will not work with recursive, guys. It has to be explicit. Okay? So that's an explicit formula that represents the sequence. And then this bottom number is going to be the first term number. Whoops. The first term number. And then, of course, the top number is going to be the final term number. So let me explain this using this actual example. If we want to find the sum of 2n from the first term to the 5th term, we're literally doing this. How would I find the first term? Remember how we deal with explicit formulas? If I want to find the first term, I do what? I plug in 1. I plug in 1 to what?
N.
2n, right? So if I want to find the first term, wouldn't I just go 2 times 1? What if I want to find the second term? 2 times 2. What about if I want to find the third term?
2 times 4.
2 times 3.
Just kidding.
I know. If I want to find the fourth term,
2 times 4.
and then finally, because it wants me to go all the way to the fifth term, I would find that fifth term by doing 2 times 5. But we don't want to just find the first term, second term, third term, fourth term, fifth term. We want to do what with them all?
Find the series.
We want to find the series. We want to add them all up. So we're going to take 2 times 1, which is what? And we're going to take 2 times 2, which is? 2 times 3, which is? 2 times 4, which is? And then 2 times 5, which is? And we're going to add them all up. Then we'll have the sum of 2n from the first term to the fifth term. So what is 2 plus 4? 6 plus 6? 12 plus 8? 20 plus 10? So the sum of the series from the first term to the fifth term is 30. That's what we're doing when we see summation. Y'all follow that? Now watch how annoying this is. Alright, let me show you this. Let me show you number 5. You see how the instructions say expand each series and evaluate? This is literally what it means. We want to find the sum of n minus 1 all the way from the first term to the 12th term. So guys, how would I find just the first term? How would I find just the first term?
1 minus 1.
1 minus 1. Plus, how would I find the second term?
2 minus 1.
Plus, how would I find the third term?
2 minus 1.
Plus, how would I find the fourth term?
You
4
gotta do that all the way.
minus 1.
Plus, how do I do the fifth term?
5 minus 1.
Sixth term? Seventh term?
7 minus 1.
Eighth term?
8 minus 1.
Ninth term?
9 minus
10th term?
1. 10 minus 1.
11th term?
Some more?
And 12th term. Okay, how annoying was that? So annoying, especially when, what is 1 minus 1?
0.
What's 2 minus 1?
2, 4, 1. 1.
What's 3 minus 1? 4 minus 1? 5 minus 1? Get the point. So it's plus 5, 6, 7, 8, 9, 10, all the way to 12 minus 1, which is 11. And then we're going to add them all up. What is 0 plus 1? 1 plus 2? 3 plus 3?
6.
6 plus 4?
10.
10 plus 5?
15.
15 plus 6?
21.
21 plus 7?
28.
28 plus 8?
36.
36 plus 9?
45.
45 plus 10?
55.
55 plus 11.
66.
So my answer, the sum of this series, n minus 1,
Wait, what
from
about-
the first term to the 12th term is 66. What were you saying?
I was gonna say 12, but it's 11.
Alright, was that fun?
No.
Y'all want to do that for every problem?
No.
Sure.
No. Let's go to a calculator.
Okay.
I'm going to show you guys how we're going to do this using an awesome button in our calculator. Ready? Bet. 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 Okay, here we go. So, in your calculator, I want you to click on, I'm about to beat y'all up. Beat you up. We're going to go to, we're going to go to alpha, window, number 2. And my calculator didn't have this button when I was y'all's age, so feel sorry for me. You're going to apply a variable. What's the easiest variable to type in your calculator? So just go click X. And we're going to do this problem again. We're starting with what term?
1,
And we're going to what term?
12,
So fill in those spots. And we're doing what?
X minus 1.
We're going to use our X instead of N minus 1. And we're putting everything inside that parenthesis. That's a key. In fact, the last problem I'm going to show you here in just a minute, people make a mistake on this, but watch. Push enter, and voila.
That's looks like you didn't have it.
I know.
Yeah, that really
It was upsetting, huh?
You said that for one of them.
Yes, I did. I'm pretty smart.
I know.
Okay, let's go on down to number 8. We're going to do 3 more real quick. Alpha, window. Number 2, assign a variable. I like to use X. I'm not going to keep saying that. I'm just going to start doing it. We're going from what term on number 8? From the second term to the what? 8th term. So that means we're starting with the second term, going to the 8th term. For what function?
I'm pretty sure it's not.
You're right. I'm old and can't see as good. Yeah, but that has nothing to do with not being able to see. And what's my equation? 2x minus 7. Push enter, and boom. Just like that. 32.
So any variable on here, we can just substitute with that.
Yes, any variable, because you'll never have multiple variables for these problems. So whatever it is, if it's A, put X. If it's C, put X.
Why do they use different variables?
I don't know. Just personal preference, I guess. Mixing it up, keeping things crazy. Makes the worksheet look prettier. I don't know. All right, so let's look at number 10. Assign a variable. I'll replace C with X. I'm going to go this time, Aiden. It is 2 to 8. I must have been ahead. This one I'm doing a fraction, though, so I'm going to go alpha y equals number 1. And I'm going to put x cubed over 2. Now, this one, it gives me, do y'all remember what kind of fraction that's called? It's improper. If you don't like it, y'all know how to change it in your calculator to a mixed fraction? Go alpha y equals, and y'all see number 3, how it says n over d? That's improper. To u n over d? That's mixed. So go pick number 3, and it'll change that for you real easy. 647 and a half. Okay, that's a nice button to know in your calculator. Yes, sir. You go same spot, alpha y equals, but you do number 4. Number 4. F to D, fraction to decimal, vice versa. It would go either one. Yeah, either one is completely fine with me. Now, the trickiest one, I want you to go down to number 12. The trickiest one is number 12. Let me show you why. Don't forget, number 12 has that 3 times out in front of it, right? So that's the first reason some people miss it. They forget to do 3 times. So do 3 times. Then go pull up your summation. Alpha window number 2. Assign your variable, x. We're going to do from the 4th term. We're going to do from the 4th term all the way to the 8th term. And here's the trick. When we do summation, everything that's a part of your equation has to fit inside those parentheses. So what happens a lot, and this is wrong, people go like this on this problem. They go 4 minus x, and then they come outside those parentheses and put their squared, and that is wrong. That is going to take 3 times the summation, and it's going to get all those values and then square it. That's wrong. 4 minus x squared is your equation that you're using summation on. So here's how we do that instead. I'm going to delete this and show you. Everything has to go inside these parentheses. So if I'm going to do this, I'm going to go open parentheses, 4 minus x, close parentheses, squared. That's how you have to do this. All of your equation has to fit inside the original parentheses for that summation. Yes, sir.
Can you square before you do it, or is that not that important? So, like, could you do 16 minus x over 2? Or no?
No. Because remember, 4 minus x squared is really 16 minus 8x plus x squared. Because it's 4 minus x times 4 minus x. You could do that if you wanted, but that would be a little trickier than just typing it in with parentheses. So there you have it. The answer is 90. Okay, that's the correct answer. So please be careful when you have parentheses in your equation. You might have to double parentheses, and that's okay. So your homework is the worksheet from last night, numbers 16 through 24. Y'all looking at it? 16's on the front, and then all of the last ones, 17 through 24, you're just typing them into your calculator. I know the instructions say to expand, but I'm not going to make you. Just type them into your calculator. I need you to practice that.
On a test, would we have to expand?
No, I won't. No way.
Did you have to expand the
There was a way to type it into the calculator. It was just a lot more complicated. A lot more complicated. So your homework is numbers 16 through 24 in last night's assignment. Y'all with me? Okay. Go ahead and do them now because you have. Oh my goodness, what happened? Y'all, I talk too much.